Okay, quickly, reactions involving hydrocarbons. I know many of us are agitating. When are we going to get to naming of compounds? Just calm down. Let's deal with the basics. This is why many students are having issues naming compound, because they did not deal with the basics. They just went ahead. They just learned alkanes, all right, and they move ahead to start naming compounds, and they encounter some difficult compounds with different functional groups which they have not been exposed to, and because of that, they start having issues. And then they come to the conclusion that organic chemistry is very, 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 very hard. It's not very hard. It's very simple. Just learn the basics. If you learn the basics of any project you venture into, when you go high up there, you won't have issues. All right. Reactions involving hydrocarbon. I think I've explained this in the previous classes. Substitution reaction. Substitution reaction I told us it is the most common reactions alkane undergo, and I think this reaction I've given it to us before, so I won't waste much time on this. Don't forget this substitution reaction, most times they may ask you in the question, what kind of reactions do alkanes undergo? You may not see substitution here, but if you see chlorination reaction, you can pick that as the answer, because chlorination reaction is an example of substitution reaction. So don't be confused. In case you did not see substitution reaction in the option given, you will see chlorination reaction. And this reaction, they will ask you, it takes place in the presence of sunlight. Yes, it takes place in the presence of sunlight. That UV you see there on the arrow is ultraviolet rays. That's sunlight. Ultraviolet rays. That's the catalyst. So that reaction is catalyzed by light. Don't forget that. It's another question that Jamb normally asks. So substitution reaction rather, it's a common reaction undergone by all alkanes. Next is combustion reaction. Yes, I've explained this also to us. I told us combustion reaction does mean reacting a compound in the presence of air, oxygen, okay? And that's the formula given here. I told you, if you want to carry out any combustion reaction, that is the formula. You will get the balanced chemical equation if you apply this formula. The note is very explanatory. All right, like I told us before, when you react an hydrocarbon in excess oxygen, you will get what? Carbon 4 oxide and water. That is a constant product. Those are the constant products rather when you react an hydrocarbon with excess oxygen. So try out the formula, put in any value, put in any hydrocarbon, and try an alkane, try an example of alkane, try an example of alkene, try an example of alkyne. Put in your values into those slots, you will get a balanced chemical equation. The next one is addition reaction. I told us the last time, only alkenes, ene, and alkynes, yne, undergo addition reactions. Alkane do not undergo addition reaction. An addition reaction, just addition of hydrogen to an alkene or an alkyne. Like I told us the last class, when you add hydrogen to an alkene, it breaks the double bond, all right, and the corresponding alkane is formed. Similarly, when you add hydrogen to an alkyne, the triple bonds are broken into double bonds. You get the corresponding alkene. But when you react double moles of that hydrogen compound, it will break the alkyne to alkene and also break the alkene to alkane. So they may ask you, when you add a complete number of moles of hydrogen to an alkyne, what is the final product? The answer is an alkane. But when you just add it normally, just add the normal 1 mole of it to alkyne, you will get your normal alkane. When you add 1 mole of hydrogen to alkane, you have your normal alkene. When you add 1 mole of hydrogen to alkene, you have your normal alkane. Let me go over it again. All right. When you add 1 mole of hydrogen to alkyne, it breaks one of the triple bonds. Then you have a double bond, which is an alkene will be formed. When you add 1 mole of hydrogen to an alkene, it breaks the double bond, and that means an alkane will be formed. But in the case where you have been asked, when you add the double number of moles of hydrogen to an alkyne, what will be the final product? It will break the triple bond, break the double bond, and what will be left will be a single bond. So that means when you add the double number of moles to an alkyne, the final product will be an alkane. So the reactions, they're very explanatory. Ni there stands for nickel catalyst. Nickel catalyst. All right. Nickel, check. Look at the first example there. The double bond is broken into single bond. Can you see it? The double bonds are broken into single bond. You can also use bromine. All right. You can add bromine. You can add hydrogen. Addition reactions. All right. Then polymerization reaction. I talked about that in the last class also. The linking together of many units of simple molecules called monomers to form a complex molecule called polymers. So you're reacting monomers together, smaller units of a simple compound to form a polymer. So monomer plus monomer, you get a polymer. That's polymerization reaction. And one of the common hydrocarbon that undergoes polymerization reaction is ethene, C2H4. Ethene undergoes polymerization in the presence of pressure, catalyst, and temperature to give polyethylene. Don't forget that word poly means large, many, polyethylene.